Okay, so tan curves, we're going to look at this first example here. Now, first of all, I'm going to think about the period. Now, there's no n value here, so the period's going to be pi. But this distance between negative 5 pi and 4 and 5 pi and 4 is 10 pi and 4, which is 2.5 pi. So I'm going to see about 2.5 cycles of my tan graph. So to begin with the tan curve, I mean your standard tan curve you need to be familiar with would look something like this. I know that the first asymptote is at x equals pi on 2, and my normal tan curve would look something like this. Then there's another asymptote at x equals 3 pi on 2, and my tan curve, of course, as I approach asymptotes, I get closer and closer, where this would be 0, 0, and this would be pi 0. That would kind of be my normal tan curve. And so here, what I'm seeing is that there's a translation of 1 unit in the positive direction of the y-axis. So what we'll do is begin, of course, with our axes, x and y. And I'm going to draw a guideline at y equals 1. Again, don't label this with an equation, as it's not an asymptote. It's just for our benefit. It's a guideline. Now what I'm going to do is I'm going to find the starting position. Now, the translation is 1 unit positive direction of the y-axis and pi on 4 positive direction of the y-axis. So we're going to go pi on 4 this way. So here, at pi on 4 and 1, I'm going to call that my starting position. Now, what you'll notice is that if this is a normal tan curve and this is my starting position, if I add half the period, I get the first asymptote. So that's what we're going to do here. We're going to come to the starting position and add half the period. Now the period is pi, so we're going to add pi on 2 to pi on 4. Pi on 2 plus pi on 4 will give us 3 pi on 4. So here at 3 pi on 4, we'll sketch our first asymptote. X equals 3 pi on 4. Now, if I add the period, I'll get 7 pi on 4. There'll be an asymptote at 7 pi on 4, but that's beyond our domain. Now let's look the other way. If I take away the period, so 3 pi on 4 take away pi is negative pi on 4. So yes, I can draw that asymptote. X equals negative 3 pi on 4. Oops. Don't use pen. Oh boy. X equals negative pi on 4. And let's take away the period again. Will give us negative 5 pi on 4, which will be part of the period. And in fact, it's going to be the end of our domain. So x equals negative 5 pi on 4 over here. And that's definitely how I start with my tan curves. I want to get the starting position, where's the center, and get my asymptotes on the page. Now, because the period is pi, that means the graph repeats at pi. So if I have a point here at pi on 4, then I know that I'm going to have another point here, pi units, to the left of that point. I also know I have another known point, pi units, to the right of that point because the period is pi. But if I add pi to this, this is pi on 4. If I add pi, I'll get 5 pi on 4. I've got a round bracket here. So 5 pi on 4, it's going to be hollow endpoint, which we do need to label with coordinates 5 pi on 4 and 1. Our other endpoint, of course, is an asymptote. The last thing we need to look at is y-intercept and x-intercepts. Let's take a look at the x-intercepts. Or, you know what, y-intercept. Y-intercept's always the easiest one to start with, so let's look at the y-intercept. For the y-intercept, I'm going to sub in 0 into my equation, of course. I've got tan minus pi on 4 plus 1. Now, again, need to know your cast, need to know your triangles. I have it in my head, but just for benefit's sake, let's draw it out. Minus pi and 4 is going to be here in quadrant 4. So only cosine is positive, so the answer is going to be negative. And of course, this is going to be the 1, 1 root 2 triangle with pi and 4 here. So tan of pi and 4 is 1 and root 2, but it's negative. What am I talking about? Sorry. Tan, tan, opposite over adjacent. Tan of pi and 4 is 1 over 1. But because it's in quadrant 4, it's going to be negative 1. So I've got y equals negative 1 plus 1, which is 0. So my y-intercept is 0, 0. And I'm going to label that on my curve. Now you're thinking we need to find x-intercepts, but we do know the period is pi. So if I add pi to 0, I'm going to get pi over here. And if I take pi from x equals 0, I'm going to end up over here at negative pi. And so in fact, that has given me all the x-intercepts. Now, sometimes you can do this because it's going to be nice. Other times you're going to have to figure out by letting the equation equal 0 and solving for x, just like we did with the cosine curve before. But in terms of what happened here is I have all my points. So the last thing is to make sure I get the shape right. So let's try and get this right. Make sure as I'm getting towards the, as I head positive and negative towards infinity for y, that I'm approaching my asymptotes and I'm not going away from my asymptotes. And so I just want to get the shape nice and clear. And so I'm just going to check. Asymptotes are labeled with an equation, very important. All my intercepts and endpoints have coordinates. Okay, so that's what we'll need to look at for this double. It will largely take the whole double. What I'd encourage you to do is to do all questions on both sheets first, and then use your calculator to check your answers. Have a look at your neighbors. Let them know if the shape is not correct or if they're not labeling things correctly. And when I see you guys again next, we'll move on to some new topics for circular functions. Thanks, guys.